So I've been at ET Pathfinder for 2 months now, and it has been absolutely amazing. And I'm honestly kind of sad that I'm leaving. But before I leave, I wanted to make sure that I recorded the different videos that I promised about Einstein Telescope and ET Pathfinder. And with this one that we're starting off with is, what is the Einstein Telescope and what is ET Pathfinder? The Einstein Telescope is a third-generation gravitational wave detector, and there's a whole bunch of different third-generation wave detectors. This is just one of them, but it has a whole bunch of new technology. And so a gravitational wave detector, what gravitational waves are, for those who don't know, is those are ripples in space-time that are caused by massive events in the universe, like black holes merging with each other, that basically is just, it's such a huge event that it's actually like rippling and causing shock waves through space-time. We use something called interferometry to be able to detect the gravitational waves. So in an interferometer, usually they kind of look like a 90-degree corner, and at the end of each of the arms there is a mirror. There is also, the other main part is that there is a laser. This laser at like the direct corner part there is a beam splitter that splits this laser into two different beams that then each hit the mirror. Because lasers are at a very specific speed, because speed of light, you can actually tell the distance between the sensor and the mirror, because the laser hits the mirror and then bounces back, and when the two lasers bounce back to each other, they create something of like an interference pattern. From the interference pattern, you can tell the distance of the two lasers. Basically, what happens with gravitational waves is that when a gravitational wave comes by, the space between the mirror and the sensor changes. They either can compress or extend, and that obviously changes the distance between the sensor and the mirror. So since this changes the distance, it changes the interference pattern that we can see, and from that change in the interference pattern, we can tell that a gravitational wave happened. The thing about gravitational waves is that they are incredibly faint signals because they are from objects that could be billions of light years away. And also, because it is then has to be such a sensitive instrument, literally anything that shakes the instrument will cause a signal, and it starts to get really hard of being able to actually tell what is a gravitational wave and what wasn't, and it gets into this whole thing. So scientists have been coming up with a bunch of ways to be able to handle that and handle all the different noise that can also just come from the system itself. And with each generation, we get better and better technology, and the third generation has, like I said, for Einstein Telescope, a whole bunch of new technology. First off, well, it's not exactly new technology. The first main thing of the Einstein Telescope to help with noise is that it is going to be underground. A lot of the other ones that we have, like LIGO, is above ground, which means like trucks driving by can bother it, a tree falling, all of those sort of things can all cause issues. But now that it's going to be in the ground, you're not going to have as much environmental noise, and it is going to be like 200 to 300 meters under the ground, so it is going to be quite down in there. Another thing too that's really interesting about the Einstein Telescope is that it's actually in a triangle formation with a whole bunch of multiple interferometers. There's actually going to be a total of 6, which is really interesting, and I'm doing another video about why exactly it's a triangle and going into more in depth in that, but I don't want this video to be too long. They're also adding a cryogenic system to the whole thing to help with decreasing the thermal noise from the mirrors themselves, because yes, the literal just mirrors existing can mess up the signal if they're not careful. So there's going to be the cryogenic system added, but because of the whole cryogenic system, they actually have to change the material of the mirrors. So they're going from fused silica to crystalline silicon. And I'm going to be doing a whole video more going directly into this, but basically the different materials react differently in the cold, and fused silica is not that good for the cold, as well as because of switching the material, they have to actually switch the wavelength of the laser that is typically used. And again, I'm doing a whole video to go into that because that is its whole own thing, and it's really interesting, especially for me because I really enjoy optics. So all of this technology is actually pretty new to the world of gravitational wave detectors, and because of that, that is where ET Pathfinder comes in. So ET Pathfinder is the prototyping facility for being able to test all this different technology, specifically of being able to test all the different systems together. Because there's a lot of other places and a lot of different universities involved in this project, and they're making all the different things like individually, and then they come here to be able to test it, because in like the clean room that you can see behind me, we got like some of the different towers, and it's basically it's an example interferometer, and they can test all the different stuff to make sure that it all works, and it is really cool. And where the main area I have been spending has been this boxed off area, which actually, since the last time I was in there, which has been like a week or so, they added an entire new curtain to that, so that kind of threw me off when I came in here to record today. So this huge gray curtain over there is what we call the laser corner. And the reason why that is all blocked off is because it is a really powerful laser, and it is a really scary laser, because it is an infrared laser, which means you cannot see it. And also if it hits your eyeball instantly gets a hole in it almost. So it can be a little bit dangerous if you get like the direct laser. There's usually what you're more worried about, because you're not sticking your eye directly where the laser is more just scattering off of the optics. Which still can be dangerous actually for your eyes, because then like prolonged and it degrades your eyes and it's a whole thing. So when you go in, you have to wear like special goggles, and so it's blocked off to make sure the laser doesn't go anywhere else into the clean room, so that when people are working on the actual like more mechanics part, they don't have to worry about wearing the goggles, because the goggles fog up really bad. Anyways, someone asked on my last video what actually the grade of the clean room is, and according to the ET Pathfinder design report, it is, looking at my note about this, ISO 14641 Class 8. And if you don't know what that means, don't worry, because I didn't either. I had to look it up. And with the ISO 14641 is that it is the name of the standard that clean rooms then have to be held to. And the class type, Class 8, is one of the least stringent clean room classifications, where basically you just have to have a kind of moderate contamination control. There's not like, you don't have to like go into like full hazmat suit sort of deal. What you instead go into is something that I've like heard a lot of people call bunny suits. And what the specific numbers are, if you're interested about that, is that, so the classes are based on the maximum amount of particles that you can have in the air, which for Class 8 is, I'm again reading numbers, 3,520,000 particles per cubic meter. And that is for particles that are greater than or equal to 0.5 micrometers in size. And what those mean for that size is those are particles like skin flakes, the fiber off the clothes, hair, pollen, dust, all of that sort of stuff. So when I go into the clean room, I have to get all suited up to cover most of my body, and so that those particles don't go flying around onto the optics and electronics. And there's also this room that you go into after suiting up that basically blows a bunch of air to try to blow a bunch of stuff off. I also have to clean off anything like my phone if I bring it in there, or any electronics with isopropyl alcohol, that sort of thing, to make sure that there isn't dust. But yeah, it's like a whole process, and it's really cool. I think I have a video actually of it.
So this is the bunny suit that I mentioned earlier. You kind of get a full view of it. If you hear some squeaking, that is from the rubber of the overshoes that I'm wearing that we have to put on to protect. That sound there is the sticky mat. It is basically I am stepping on flypaper. It's to clean all the dirt off. Now, if you look at here, you can kind of see all the vents on the walls. There is a whole bunch of air coming from all of those vents. It is almost like if you stood in any of those tornado type of deals. It's the same thing. It's blowing a whole bunch of air around, circulating it around so that you can get all of the dirt off. It takes a little bit, and then eventually it starts slowing down so that in there you can see the clean room through the blue door. It's kind of cool seeing it through the blue, honestly. So now I'm stepping in. Got more sticky mat. And now it is really quiet in here. There's basically almost no sound.
If you guys have any questions about the Einstein telescope or ET Pathfinder or anything else like, about my time here, gravitational waves, anything, I will do the best that I can to answer them. Again, unfortunately, this is my last day here, and I'm recording a couple of videos of the stuff that I think you guys would really be interested in, but if there's anything else, I would love to know and do those videos. But I can't do them here. Also, since I won't be at the internship though, I will actually have time to write and record videos, because I know I've kind of been very busy because I've been working here a lot and for my internship. So I can hopefully then respond to all of your questions and be able to make a bunch more videos.